So we're going to do some implicit differentiation today with finding straight lines. So this is a very, very common sort of exam one. Let's take you through. So we've got some equation here. We've also got the condition that y has to be a positive number, and we've got to show that to start with. So let's handle this one first. There's a dx in the denominator, which means we're differentiating the x's. So what we're going to do over here, x squared, we're going to say is 2x. So that's differentiating the x's. xy is a bit more complicated. So remember, a shortcut for the product rule is to keep a piece and differentiate a piece, and differentiate the first piece and keep the other one. So we're going to do that. So we're going to keep, for the first part, we're going to keep the x and we're going to differentiate the y. So how do we do that? Well, because we're doing implicit differentiation, it's sort of 1 dy dx, okay? Because if you're differentiating with respect to y, you would get 1. Yes, that's kind of the nice number. But because you're differentiating a y with respect to x, it needs to be dy dx. So instead of writing 1 dy dx, I'm just going to write dy dx. Okay, and then we're going to differentiate the first bit, which was the x, so that's a 1, and then we're going to keep the other bit, which is a y. Okay, so this part here is what the xy is going to differentiate into. Finally, y squared. So again, a bit more practice of our implicit differentiation. So y squared, the answer that you want to say is 2y. But the problem is you're differentiating there again with respect to y. So to fix it, what you're going to do is you're going to add a dy dx there, because it has the net sort of effect that you are differentiating with respect to x, which is what we should be doing. Okay, so 2y. Finally, the 10 is going to become a 0. So that's the first part there. Just checking my work, though. I'm missing a dy dx, aren't I? So that's a dy dx equals 0. So what's the next part? The next part is going to be to try and get all the dy dx parts together. So move them all to the same side, move everything else to the other side. If I look at here as well, minus 2x, and I've got 2x. So it's slightly easier if I move the pieces and keep the dy dx parts here. So let's do that. X dy dx plus 2y dy dx equals minus 2x minus y. Factorize out from dy dx because it appears twice or in two different places. So x plus 2y equals minus 2x minus y. Final answer then is dy dx equals minus 2x minus y over x plus 2y for the part A. Okay, so that's all well and good, but the idea is we're going to do something with that now. So the point A, I think the point A is new, lies on the curve. So there's a coordinate, there's a point on here. It has an x value of 1. Well, the first thing I'm kind of thinking is, well, you know, what's the y value then? Next, find the equation of the normal. So normal, how do normals work? So normals, when you have tangents, remember they copy the gradient. When you have normals, they do the negative reciprocal. So I need the sort of the negative reciprocal, and I need to use it with a coordinate, don't I, if I want to find an equation, giving my answer in this format. Okay, so I think we're kind of ready to have a go at it. So first thing we're going to do is we're going to try and find our y value. So if I sub in x equals 1, what do I get? So I get 1 plus y. 1 plus y squared equals 10, which is a quadratic. If I solve my quadratic, I get 2 values, but only one of them is a positive value. So I'm going to give it, this is in surd form, okay? But the answer is this. So I get this answer over here. So that's probably why this piece of information is here. Okay. So I've got x and y. What's the next thing to do? Well, I want to find the gradient at x equals 1. And then I want to find the normal of that. So let's go to my gradient over here and kind of do some work with this one. So there's a few different ways you could do this. I'm going to still sort of sub into the original value. So I'm going to do the gradient at 1, which is equal to minus 2 lots of 1, minus, now this one's not so nice because it's this sort of surd, isn't it? But let's just write that in. So minus 1 plus root 37 over 2. And that's all going to be over just a 1 plus, what's this one here? This is 2 lots of minus 1 plus root 37 over 2. Is it a show that question? No, it's not a show that. So what you might even do at this point here is you might try this on your calculator. You might find that it's not quite as bad as it first looks, okay? Yeah, so what you'll end up finding with this is that this whole part here ends up giving you a gradient of actually minus 1. Okay, so I think you could just put this one in the calculator as it doesn't say sort of show that. But if you did want to work through it, you know, you absolutely can do that and cancel and all this sort of stuff. But it ends up giving you a gradient of minus 1. So it's not as bad as it first looks. However, that's the tangent, okay? The tangent is giving you a gradient of minus 1. So how do you get the normal? You do the negative reciprocal. You do minus 1 over the answer, which just so happens to be minus 1. So the gradient of the normal actually ends up being a positive 1. So now that you know that, well, what do you have to do? Well, the final part is you're going to use these two parts with the gradient to make the equation of a straight line. Okay, so we could do y minus y1 equals mx minus x1. And if we do that, what we're going to have here, so we're going to have a y minus, I'm going to just leave this, I think, in a bracket, minus 1 plus root 37 over 2. This m is actually just a 1. So it's a 1 and an x minus 1. So over here, this gives you x minus 1. And then I'm going to add this result to both sides for the other part. So I would get y equals x minus 1, and then I'm going to think of adding this piece to both sides. So I'm going to do minus 1 plus root 37 over 2. And if you do a little bit of tidying up with this, for example, if you end up saying that that's a 2 over 2 to help tidy things up, you should end up getting to a final answer, running out of space slightly now, you should end up getting to a final answer of y equals x minus root 3 plus root 37 over 2. Yeah. Well, there's a few ways we could write that, something like that. Okay, so that would be our final answer. So the steps that we're going through is we have some implicit differentiation. So that's what this skill is called, if you're struggling with this one here. And then underneath, the focus is that we're using it. So we're using it with an x value, but also a y value. And it's kind of up to us to find that y value for ourselves sometimes. Sometimes it's not given in the question. Finally, we're using our skills related to straight lines to help us work through it. Okay, so this should be the final answer that you get. I've got another version on the screen for you to have a go at that makes you sort of practice some more of these similar skills. So pause this video and have a quick go for yourself. Now, the first part is a show that. So, you know, you should, well, when you have this format, that means you've got the correct part here. In terms of the differentiations going on, some of them are a little bit tricky. So this one here, I would say, is on the tricky side. So ex to the y, let's think about how to do this. So let's do the inner differentiated, okay, times the outer, because the inner part is the hard part. Well, xy, you might remember from the video a minute ago, if you do keep differentiate plus differentiate keep, you will get x dy dx. That will be the keep differentiate part. And differentiate keep will give you a y. So that will be the inner part differentiated. The outer is just e again. So that's kind of what the first term does, ends up doing something like that. All right. The natural log of y is going to be a 1 over y dy dx. Okay, and the equals 5 is just going to be a 0. What would we do from there? Well, we would expand things out. Perhaps that might make it slightly nicer to work with. So if you have xe to the xy dy dx, and then the other one will be plus y e to the xy plus 1 over y dy dx equals 0. You know, hopefully from there you should find that you can sort of almost see where that result is coming from. Okay. In terms of using the result, so on this one you have the x and the y value. So this is about a tangent. A tangent copies the same value. So what you're going to do is on this part here, yeah, you would sub in x equals 1, y equals 1. Okay, and if you do that, you should get, what do we get for that one there? You should get m equals minus e, so things simplify a lot. That's the numerator there, over e plus 1. Okay, so it simplifies really, really nicely. Finally, the equation of the tangent, we're going to write out y minus y1 equals m, x minus x1. We're going to sub in our values, which is y minus 1 equals m. M is a bit complicated on this particular question. So it's all of that, and then it's x minus 1. And if you work it forwards, you should be able to get this final answer. So where are we? Okay, down here, you should be able to get this final answer.